So, by the way, let me just clear something up. My last name is not Piano, so I just wanted to make that clear. Anyway, I'm really excited to be at React Rally. This is the fourth time that I've been here, attended twice, and I talked in 2017 about an equally boring topic, which was state machines. But thankfully, I might or might not talk about state machines again today. We're talking about the terrible concept known as testing. I think I could speak for everyone, or mostly everyone, in saying that testing is terrible and it's a painful thing that none of us want to do. And apparently it's a controversial topic too, but at least I'm not talking about CSS, so we could just move on to testing. And it's that a lot of people have really strong feelings about testing. And so my thinking is that we really have strong feelings about writing tests, not necessarily testing itself. And so I put out a poll, and I wanted to wonder, what people disliked most about testing applications that they've written. And the majority of people just absolutely hate writing tests. And a close second is updating and maintaining those tests as well. And so what I want to talk about today is how we could fix this first point, not by making testing more enjoyable to write, but just eliminating it altogether. And at the same time, we're going to be covering updating, determining why tests fail, and discovering edge cases as well. So if you take a look at your code bases, you'll see that as requirements grow, your lines of code grow too. And it is a mathematical fact that the lines of code needed to write tests are so much greater than the lines of code that you write in your application. Because if this is not the case, then you are missing tests. So as requirements grow, your tests grow. I wasn't able to fit it on the screen, but they grow exponentially. And the problem with this too is that requirements, you see this curve, it slows down because they say, all right, they have enough tests to write, a lot of code to write, and so you're not able to get features in. Instead, you're spending time writing all these lines of code instead of doing all the feature work that you should be doing. So there's two schools of thought for this. You could either write a ton of tests, as many as possible. I call this the write tests frequently technique. And it's by Dan, so you know it's a good technique. Or you could be like Brian Florence and just write code perfectly the first time, which apparently is what he does. Or like Michael Jackson, who wrote the expects library, you could write, a unit testing library and, encompass techniques like red-green refactor, or, well, because it's Michael Jackson, it's black and white refactor instead. It makes you have unbreakable code. And funny enough, his repro is broken, but that's just human nature. I'm sorry. I see some of you walking out now. I totally get it. So, here's what we were doing before test automation became a thing. We manually tested the code. A lot of you remember the pain of this. We would write the code, and then we would look at the business requirements, and we would manually execute our application, clicking things and typing things, and just making sure that our code worked. Or better yet, we would hand it off to QA, who always found a way to break our app, no matter how good our code was. Thankfully, this got a bit easier when we started automating our tests, because instead we could write these unit and integration tests for our code and have them automatically run, hopefully as part of the CI/CD process. But what we're going to talk about today is modeling the code so that we could automatically generate exhaustive tests for every possible thing the user could do in the app. And this isn't the only level. There's something called formal methods where you could formally prove that it's impossible for your code to have bugs. This is actually a thing, and some companies do this. But the highest level of enlightenment, which maybe I'll talk about one day, is just delete your code, because then you don't have to write any more tests. So this is a testing trophy by Ken C. Dodds on his Testing JavaScript website, and it talks about the importance of tests. We have static tests where this comes from types, whether you're using TypeScript or if you're using Flow for whatever reason, I don't judge you. There's unit tests, which we write most of, but we see that integration and end-to-end tests are the most important tests. Ideally, this is what our test structure looks like. But in our apps, it's less of a testing trophy and more of a testing ribbon, because it's more like, you tried. Well, what I find a little ridiculous too is the fact that the code that we write, we're writing the tests for our own code, so we're sort of validating ourselves, which doesn't make sense. We're patting ourselves on the back. And I can't think of any other industry where like mission critical safety code that might endanger the lives of others is tested by the exact same people who wrote the code. I can't. All right. I'm sorry, that might be too soon. I didn't know if that was going to fly. Sorry. So, here's my thinking. Instead of writing all these tests, what if they could be generated instead of being written? And what if these tests can automatically regenerate themselves without us having to rewrite the tests? So this is the idea behind model-based testing. And just like state machines, this is not a new idea. It's a bit younger than state machines. It's about 20 years old, give or take, where the first research paper in 1999 was written about this concept. And ever since, other industries have adopted it to some level, and there's commercial and open source tools available for this. But just like state machines, it's something that we're not too familiar with in the front end, and frankly, the native mobile, web dev technology industry that we're in. So let's do a puzzle over here. How many of you have seen Die Hard? So you might remember this puzzle, okay? From 3 and 5 gallon jugs, how do you measure 4 gallons exactly? You could pour water into one, you could transfer water from one to the other. It's a nice, tricky puzzle, and so let's try to figure out a solution. What could we do? We could, let's fill 3 up, right? And then we could transfer that to the 5 gallon jug. And then we could fill 3 up again. This is just one of the solutions that I, sort of came up with. And then I was thinking we could take the 3 gallon jug, put it in the 5, which gives us 1 gallon in the 3. And then we could empty the 5 gallon jug, pour the 1 gallon into the 5 gallon, and then some of you see it coming. We have 3 gallons, and then we pour it into the 5, and then there we go. We have 4 gallons. So speaking of water, on our break. What does this look like? Looks like a state machine, right? I mean, I don't know if I'm taking crazy pills or not, but that definitely, looks like a state machine. And in fact, we could represent this entire thing as a state machine. So if you didn't see my talk 2 years ago, quick review. You could represent your app or your components or whatever as a state machine in which we have an initial state, multiple states, events that trigger transitions between states, and possibly final states too. So that was my last talk summed up in 20 seconds. All right, so this jug game can be represented as this finite state machine. And so because of this, the solution is just following the path that leads us to one of the final states. And so this is one of 2 solutions for this, and you could expand this to similar puzzles of that type. So the important thing is realizing that a lot of things, whether it's business requirements or your component logic or even your app logic at a higher level, is a state machine. And even the browser, the computer you work on, even biological processes, even you are a state machine. It's a very important realization. So let's talk about actually turning these business requirements into a sort of state machine. You might have seen given, when, then as sort of a format for writing these requirements, such as given the user is on the home page, when they click the dashboard link, they should be on the dashboard. So we have a precondition being on the home page, an action, which is clicking the button, and a post-condition, which is being somewhere else. So this could be represented exactly like a state machine. And so all we have to do is turn that state machine into executable tests by adding assertions on each of the preconditions and post-conditions and adding some sort of execution mechanism for the action, like physically clicking a button or typing in some text in an input. So here's how we do model-based testing in 5 easy steps. First step is you create a model of your application. And so this is going to be the most important step, and it's useful not just in model-based testing, but in application design in general. So represent your app as these dots. Call them testing dots, call them Kent-C dots, whatever you want. All right, I'll stop it with the puns, I'm sorry. From there, you generate abstract tests, and all this is doing is pathfinding. So we're finding all the paths from one state, our initial state, to every other state in our application. From there, you make them real. You associate transitions with actions such as a mouse click, keyboard input, some time delay, or anything else. So we have a precondition, the action happens, and then we test the post-condition. All these need to be within the test because we need to actually execute them and make them real, because our abstract tests do nothing until we add these concretizations of tests. So then we execute the tests. The tests will follow this testing plan and test every state, every transition, and quite possibly fail. What this means is one of two things. Either our model is wrong and doesn't describe the application exactly, or our application is broken, and so it's up to you to figure out which one it is. But then, if your tests pass once you fix everything, then you could seriously profit. And what I mean by this is you're literally saving money. Because if your app requirements change, then that just means you change the model. And when that happens, you don't need to rewrite any more tests. The model will regenerate those tests for you because, again, it's just an algorithm that traces each state and each transition and tries to go to every other state. So let's do a really quick example over here. Let's say that I have this very simple feedback app where if you click good, it goes to thanks for your feedback. If you click bad, it goes to this form where you have to enter why your experience was bad, and then when you click submit, it goes back to that thanks for your feedback screen. So this could be done manually, and I'm using the amazing testing library React library by Kent-C Dodds as well. And over here, when we're pulling things from the testing library, and we are doing three things. Remember, we're doing our precondition, which is making sure that we're in a certain screen. We're doing an action, which is making sure that an action that takes us to our post condition is executed. And then we're actually checking that post condition. But this is a lot. Like we have 2 full flows, and that's already like 30 lines of code just to do 2 flows, making sure we go to the thanks screen, and this one is going to the form screen as well. So instead, I'm proposing an alternate approach. What if we represented this as a finite state machine? And I'm using my xstate library to do it, but you could just imagine this big JSON object that maps states to other states based on events. So when I'm in the question state and I click bad, it takes me to the form state. And so anyone, whether you're technical or not, can understand this state machine and be able to trace through and verify that the state machine matches the business requirements of your app. So then we get to the fun part, which is generating all of these different paths that take us from one state to the other through our application. In this case, I'm generating the shortest paths, and you could imagine a big, long JSON output that outputs all these for each state. And so, for example, there's 2 ways to get to the thanks screen. You could click bad and then fill out the form, and then you get to the thanks screen, or you could just click good and then get to the thanks screen. Because we're representing it as a graph, we are exhaustively checking all of the different ways we could get to each of these states. And so what we could do now is instead of using this xstate graph library to generate these, I'm going to use xstate test, which is a brand new library that I literally just released this morning, but don't check it out yet because deploying on a Friday is a bad idea. So I don't want any bugs or anything. And so what we could do is we could add these assertions to each of the states. And as you could see, there's one for the question state, and that's just verifying, are we really on the question state? So with React testing library, it becomes a nice one-liner where you could use expect, I'm using assert. I'm just asserting that we do have the question screen on there. Now, all we have to do is create a model using this testing library, and that model is going to do all the complicated algorithmic work of generating all of our paths for us. But again, one important step, we have to make sure that we make the events real. And so we could associate, for example, click good, we associate that to just clicking the good button. And so we could also specify test cases as well if we want to do things in the future, such as validation, like not letting them submit if they've entered nothing in. And so using this testing library, what we could do is we could generate test plans that give us all of the paths for each one of the states that we're trying to go to, and then we could iterate through those paths, do the setup, and then test those paths. So I'm actually going to show you what that looks like, but of course the final important thing is making sure that we reach every single state, and that's what this testmodel.testCoverage function is for. So let's do a demo. So I have my feedback app over here, and I'm doing exactly the code that you saw on the screen because I literally copy and pasted, so it should be the same code. And so let me just show you what this looks like real quick, just to convince you that it is actually a real app. So we have a very simple screen, and of course it does exactly as we expect, but this is us manually testing. Using React's testing library, instead, we can verify over here. And using the testing library, it's going to generate those paths and test every single state and test every single transition as well, making sure that we could reach all of these states. And just to prove that this does, in fact, reflect our application business logic, let's say that we forgot to add the submit button on the form. Now it's going to fail. Don't mind this. This is just barfing all over the place. But look up ahead. We have the path, and we could tell exactly where it failed. So you could copy and paste this, and you instantly have a test reproduction that you could share with anyone who cares to see that reproduction. So when you're on the form state, you could see that that submit button, that event failed to execute, and so when we add it back in, the tests will pass again. So. So there's many ways to generate the paths. There's shortest paths, which are literally just the quickest way to get from one state to the other. But just like you might know from driving or anything, the shortest path is not necessarily the shortest distance. In fact, we could represent shortest paths by weight, and we could, for instance, determine that users take a different path more often, and so we want to place more importance on those paths for testing. And so you would use something like Dijkstra's algorithm. I typed this like 5 times before I finally got it right, by the way. Or we could do simple paths, which are much more exhaustive. Simple paths mean all the paths that it takes to get from one state to another state without doing cycles, so without repeating states. And so in this case, there's a few of these. And so all you have to do is trace the paths, and you'll see. So this is much more exhaustive, and it's going to create many, many more paths. So you might be thinking, like, all right, I see it in the tests, but is this limited to just, testing within React testing library? And the answer is no. If we take that exact same testing model and instead add, say, Puppeteer to it, let's just see what happens. I hope this works. So instead of doing React testing library, it's going to open up a version and literally go through every single one of those paths, executing them on a real browser. And so this is going to be your full experience, and we have all the tests passing. So. All right. So you could sort of think of this as time travel debugging. I know it was talked about, but this is a little bit different. Instead of going back in time, now we're seeing all possible future events. And so this is really powerful. In fact, all right, so what does this have to do with React exactly? Absolutely nothing, and that's the point. You could do this in Vue, Angular. It doesn't matter what you write your application in. We are describing our application in this abstract model that is implementation agnostic, which means that we could use the same testing model for anything we implement our application in. And so this is a pretty powerful concept. And real quick, I wanted to have fun with how many of these paths are generated, just because over here it's generating 12 paths because we have a fairly simple application. But what if we have an application that's more in depth? So over here, I modeled a simple tic-tac-toe game, and I used a state machine, of course, because that's me, that's my whole persona. And I used a state machine to model this tic-tac-toe game. And so the machine is over here. It's a pretty simple machine. This is what it looks like. Don't know if you could see that, but we have 3 states playing winner and draw, so you could sort of imagine just a game loop running as you're playing through it. And so, we had that. Oh, is this going to tie? Yeah, it's going to tie. But anyway, you get the idea. Now, because I have this state machine, I thought, can I use this same machine to both power the app and power some, I don't want to call them tests because it's going to get a bit crazy, I'll show you. But what I did was I took this machine and I mapped each one of the events, the player events, to actually clicking a square. So whatever the value is, whether it's the 0, 1, 2, 3, 4, 5, 6, 7, 8 square, I'm just finding that square and clicking it in Puppeteer. Now, because this generates about 5,100 tests, didn't want to do that, so I narrowed it down. I said I want all the paths where the state matches winner, there's more than 5 moves, and the winner is X. So hopefully it will do that. And so it's going to launch the app, generate all those paths, and then we'll see if it loads. There we go. So it's going to find every single game combination where X wins and fits a criteria. All right, let's stop this before it gets out of hand. All right. So I released X8 test for this, and of course, no documentation yet. But there are other similar tools for this that have existed in the past. I don't know how up to date they are, but there's a Simulato written for USA Today Network, which has similar ideas, and also GraphWalker, but that's for Java. I should have looked at that. I did the recruiter move. I'm sorry. That's for Java, not for JavaScript. So I'm going to be honest with you. Model-based testing is harder. And I don't mean in terms of effort, I mean in terms of mental energy, because there is a learning curve to how you model your application and just learning the art of modeling so that you could represent your application in these state machines or state charts. But it's also better, faster, and stronger for many different ways. It's better because you're going to cover many more edge cases than a human can even determine manually in their lifetime. It's also going to be faster because you no longer need to update tests or write tests. All you have to do is update the model if it needs updating, and in case you want to support different platforms, different browsers, different frameworks, you just update the model tests. And so these are going to result in stronger tests because you are covering all of those edge cases. You are tweaking how fine-tuned and how much coverage you want your tests to have. And this is possible with model-based testing because we're not writing tests. It's the entire point. So these X8 tools are part of this whole idea of model-driven development. And that's why I say that X8 is so much more than just a finite state machine library or just another state management tool. How many of you use Gatsby? All right, a fair amount of you. So Gatsby actually uses X8 under the hood in order to manage some complex processes like file watching and stuff like that. Also, React Training uses it for their payment page. I use it at Microsoft because I work at Microsoft and I could do that without them knowing. And it's also used at other companies, which I'm not allowed to say for whatever reason. And it's also used for this really fun game. Some of you might know it. It's called Service Workies. And this is a really fun game with lots of levels and complex animations which are driven by XState and by these state machines. And so the result is you get this really interactive experience which is complex and also really fun to learn things like service workers. So XState is evolving. I just released XState Test, and I'm coming soon with so many more tools for XState. Also, there is XState React, and it looks very similar to the use reducer hook. All you do is you pull this use machine hook, and you put a state machine instead of a reducer, and you have the same states and dispatch, but they're called currents and send. And it's a really powerful paradigm that you could use to power your React applications. So basically, I want to make your code model-driven, and I want you all to make your code model-driven because this allows you to do so many more things. It allows you to generate tests, generate documentation from those tests. It allows you to even generate prototypes and visuals. So in short, I want to make your code do more. Thank you, React Rally.